Welcome to my project for replication demo. So my demo setup is as such. I have these 13 open terminal windows, 12 of them open to 6 different microcloud nodes, one of them open to Stargate. These windows across the top will be running the actual Java servers. These 6 across the bottom middle will be showing the respective logs of the node above them, and I'll use this window down in the bottom right to send sort of as a client to send requests to one of the front ends using Python scripts. So my setup, or the tools I'm using, consist of one bash script and 3 Python scripts. One of the bash script, this one, it's called watch most recent log. It basically just it does that. It watches the most recently created log, which is useful to me because as soon as I execute any server node, it creates a new log file, which it logs to for the duration of its execution. The Python scripts are one called get events, which basically just pulls the system for what events are inside of it. Another one called quick test, which basically which does a create an event. It does a purchase of one ticket for that event, and it does a transfer of that purchased ticket. You'll just see status codes of 200 to indicate a success. I'll show it a little more detail when I run it. And then the third one is a concurrency test, which I'll explain at the end. So the first thing I'll do is start up my system. I'm gonna start up the primary first. So the primary is an event service, and I've given it an argument that says the primary is true, and I gave it its the URI or the address at which it will be, and the port to listen on. So I'll run it, and then I will run that log listener. So boring now, it just says the primary has started up. Okay, so now let me run a secondary. So a secondary, it's the same jar. It's this event service.jar, but that flag that it is the primary, I haven't supplied to it. So that means it will run as a secondary, and I have given it the address of the primary, which is MCO2. Oh, I should mention actually that these two, so except for the client in the bottom right, the terminal windows above and below each other are on the same microcloud, and going across, it's cloud 2, microcloud 3, microcloud 4, microcloud 5, microcloud 6, and microcloud 7. Yeah, and I'm using all the same port number for everything just to simplify this demo a little bit. And that works because they're all on different machines. All the instances are running on different machines. So now let me start this up, and we will watch its log. So you can see the first thing that happened is the primary noted that a new secondary was added, and then the actually empty data set was copied over to the secondary as it came on. We'll do the same thing twice. So I turned on another secondary, watch its log, same. Okay, so you can see here, since this was the third secondary that came on, the first thing it did was it got from the primary. It got the previously existing secondaries, so this is on MCO5. You can see this is getting 3 and 4. And then once it got those addresses, it replaced its data set with the data set, which is again empty, from the primary. The first secondary that went up, you can see nothing needed to happen. It just got each new secondary address as they came on. So 4, then 5. And then this one in the middle is sort of an interleaving. It started up, it added just the address of the third one because that was the only one on the network. It had its data set replaced with it got a copy of what the primary had, and then when the fifth one over to the right here came on, it got notified and added that to its list. Okay, so now let us add some front ends. So you can see here I'm running a different jar front end service, and we will watch its logs. So nothing very interesting, just that the front end was started, but you can see at the primary and all secondaries, there's a message that it added the front end. And again, this is on node MCO6, and you can see that 6 in the IP address here, 6, 6, 6, 6. Okay, and we'll do that also for on node 7. Watch its log, same thing, just a startup message, and then same thing, front end coming online messages on all secondaries and the primary. Okay, so now our whole system is up. Our 6-node network is up, and we can start to make some requests from the client. So as a first pass, I'll just show you that there is nothing, there's no data in the system. So, and just sort of what this get events script will look like. So it did a get, the primary, so it actually reached out to this front end at MC06. I'm not logging reads at the front ends, but you can see that it came through, and the list method on the event service was invoked, and it got a status 200 and returned all 0 events. Okay, so now I will create an event and do a purchase and do a transfer. So that's what this quick test does. And just for the fun of it, since we last made a call to MCO6 front end, let's do this to the MCO7 front end. So you can see it's logging these 3 writes, which is the create, the events, or the purchase, and the transfer endpoints. The front end, so only the create and the events are going to go out to this system because it's the event system. So you can see the create endpoint is started over here, and then it's replicated here and here and here. And then once those 3 replications finished, you see a create finish, and then similarly there was the purchase started, and then there was similarly a replication here and here and here, and then the purchase finished. And we can prove that all those things were successful by looking at the output of this script, and that so you can see it got a status 200 for the creation of this event. It got a status 200 for purchasing of this ticket. And this event ID is actually the event that we just created. And then we got a 200 on this transfer, which is only really noted in the front end, because that's the only node that it's interacting with. of these 6 nodes. Okay, so now now we'll do a get events just to show that that event got in there. So yep, you can see it just did get events. It got 200, and here's what it returned, just this one event. Okay, so now let us start with some failure scenarios. I will fail a secondary and then a front end, and then go over the logs for those. So I'll send a control C to this microcloud 5. So it shut down. In this case, the primary heartbeat discovered that secondary was down. So the first thing it did, so it immediately removed it from its list of secondaries and then sent a message to all other up secondaries saying that they should remove it also from their list. So you can see 5, 5, and 5 were all what were removed, and this is the 5, which is the one that shut down here. Okay. Now let's do that with we'll do it with front end 7. Shut it down. So it shut down. In this case, the secondary on microcloud 3 discovered the dead front end. And then it sent a message to all other up secondaries, or to all other up event services, secondaries and primaries, and the primary, to remove that front end. So removed 7, removed front end 7, and removed front end 7. Okay, so now let's test that everything is good. So we'll do a get events, should get that same one event. Yep, that's what we wanted. Now we'll do a quick test, which we have to go to yeah, we have to go to 6 this time because 7 is the one we just killed. So we'll go to 6. So yep, you can see it logged that it was doing the creation and purchasing and transferring, and then just like I showed previously, you see the creations and purchasings here, and then those replications here and here, but obviously not here because this one is down. So now we'll just pull the system with the get events, and we should see two events. So yep, 1, 2, exactly what we wanted. Okay, so now let's bring back up those secondaries, or those 2 nodes. And so let's bring back up that secondary, and I'll watch its log. So this new secondary is up. It went out, it contacted the primary. So now it logged that it was adding that secondary, and then this primary went out and contacted the old secondaries, which noted that they're adding this new secondary. So you can see 5, 5, 5. That's what this one is. And then this new secondary got the address of the old secondaries and the up front ends. So that's secondary 3 over here, and secondary 4 over here, and front end 6, which is right here. And it didn't get front end 7 because front end 7 is down now. And then the last thing it did, it went out and got a copy of all the data from the primary, which is what this dataset replaced indicates. So now let's bring up the second front end again. Okay, and we'll check out its log. So starting with front end, so now you can see that just simply the primary and all 3 secondaries got this message about the new front end coming on. So here, front end 7's on, front end 7's on, front end 7's on, front end 7's on. Beautiful. Okay, so now let's pull the system, perhaps through that new front end. So again, we should have just 2 events. Yep, 2 events. Now we will do a quick test. Let's say, so quick test again, that's the creation, purchase, transfer. Do it through MC07. So you can see we can track the replication pattern here. So primaries created and purchased, and then each secondary created and purchased, created and purchased, created and purchased. And we got all 200s back here, indicating a success. And so now if I do a get events, let's go back to the other front end, MC06, we should get, if I'm remembering correctly, yeah, we should get now 3 events. So yep, that's 1, 2, 3 events. Beautiful. Okay, so now, for the moment of truth, let's take down a primary. Okay, so this should basically, once I take this down by sending a Control-C in here, one of these secondaries will notice it and initiate an election. And yeah, and then we'll track that. And then once the election is won, the winner will copy its data set to all the losers and then send its address to both front ends so that the front ends will then know who to communicate with. So here it is. So killed it. Beautiful. Okay, so it wasn't that interesting because the highest ID'd node found it out, so it just didn't need to contact anyone. But so in that case, it elected itself as a leader and immediately contacted the other 2 secondaries. You can see which updated to 5-1 over here, so you can see this MC4 updated its primary to 5, removed 5 from its list of secondaries, and then had its data replaced. And the exact same thing happened over here at MC03. And each front end logged that it got an updated primary, which is MC05. Okay. So now we will pull the system to make sure we have those same 3 events in there. Yep, 1, 2, 3. And you can see now this time that read log happened in the new primary. Okay, so now we'll do a create purchase transfer, and we'll see the same pattern, but again with MC05 as the primary. So running it. So primary create, primary purchase, secondary create, secondary purchase, secondary create, secondary purchase. Good. And let's just do a get events just to make sure we have all. So now we should have 4 events in the system. Beautiful. 1, 2, 3, 4. Okay. So now the last thing I will do is show that I can take down a new secondary, or take down a secondary and then start one up with the address of the new primary, and and then do our creation, purchasing, pulling pattern here. So I'll kill this secondary at MC04. It shut down. In this case, the primary discovered a dead secondary. So it removed it from its list, and it told MC03 to remove it from its list. They both removed 4. 4 got removed. Okay. Now we will start it back up, but this time give it MCO5 as the primary because that MCO5 over here is the current primary. So we'll run it and watch its log. And so you can see first thing, it added this new secondary. So the primary notes that this new secondary at 4 came on. It notified MCO3 that this one at 4 came on, and MCO4, here this new one, it got the current secondary, which there's only one other of, both front ends at 6 and 7, and then got its data set replaced with whatever data was in the current primary, which is in MCO5 now. So now, if we do our pull get events, we should have that same 4. 1, 2, 3, 4. We'll do a create. So you can see it went to this front end because I sent it there. And then it went to the primary first and then got replicated at each of the 2 secondaries that are up right now. Okay. And if we do a get, we should get 5 events now because we've added 5 so far. So that's 1, 2, 3, 4, 5 events in the system. Okay, so now it is time for the concurrent test. So the concurrent test basically just takes an argument, which is the here we'll look at its output, its usage output. Okay, so it takes the front end URL to communicate via. It takes a number of tickets that so basically the concurrency test, it creates a new event with a number of tickets, and then it tries to buy all concurrently 5 more tickets than exist in the event that it just created. So I'll first run it to MCO6, and I will do it with 5 tickets. So this means it will create an event with 5 tickets and then try to make 10 one purchase tickets from that event concurrently. And every time it fails to get a ticket, it will report that it'll report that. So we should see 5 failed responses, and then we'll go through the logs of those that are still up. So okay, so beautiful. So looking at the Python script output, it created this event with 5 tickets. Status 200, success, and then it started up 10 concurrent 1 ticket purchases, and we see 1, 2, 3, 4, 5 failures. So if we go to the front end that got contacted, you'll see the same request 10 times. That's this many. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then that will go to the primary, and it will start and finish 10 of them, but it's only actually going to go and do a replication to a secondary if there are enough tickets. So that's why you only see 5 successful purchases in each of these secondary 5 and 5 here. Okay, so you can see a little bit of, this was no interleaving of the starts and purchases, but we can check, we can now sort of do the stress test version of this instead of 5, so we'll do 100, so that means it'll create an event with 100 tickets and try to buy 105 tickets. So now if we look at the primary, we're seeing mostly finishes here, but so now we can see some start and finishes interleaved here, which sort of shows the concurrency of the processes or of the requests. And then if we wanted to, we could go through and count that. There would just be 100 purchase replications over in each secondary. And then, as we expected, it only reported 5 failures at the client. And then we can even stress it harder and give it 1,000. So make a ticket, do 1,000 concurrent processes. So 1,000. So you can see things moving here and here and here. And as we hoped, just 5 failures. Because again, 1,000 available tickets, 1,005 concurrent purchases, only 5 failures. Okay, so that is my system. Thank you for watching. Thank you for watching.